All right, now let's look at functions in terms of their algebraic format, right? Instead of ordered pairs, now we have algebraic versions of functions. And we're basically asked to do the same thing, g of h of x and h of g of x. So let's start out with g of h of x. All right, and you can use brackets here too. I usually use parentheses, but either way is fine. And so basically what I'm doing, remember, is I'm putting h of x in as my input, right? So I'm taking the h of x function and putting it into g. Okay, so I'm taking the h of x function and putting it into the g, as the g was the input. So what I do, just like if there was a number here, I think I've shown you this before, but what I usually do is I just make a shell. So instead of 5x, I just put 5 and then I open up the parentheses for whatever's going to go inside, right? I actually need bigger parentheses here. So a lot of times you put numbers in there, right? But this time we're going to put this entire g of x function, x squared plus x minus 1, right? So I put that whole h of x function into g of x. And now we just simplify. So here we can distribute. And so we get 5x squared plus 5x minus 5. All right, and that's our answer for g of h of x. Okay. Now, of course, they're going to ask us to do the other way around. So now we're asked to find h of g of x. Okay. So h of g of x is where we're going to put g of x as the input for h, right? So we're going to take this function here now. Let me use a different color. So this function here, and now we're going to put that into h of x, right? So what I'm going to do is I'm going to rewrite h of x with room to put in g of x, right? So it's x squared. Instead of x, I'm going to put in g of x. Instead of x here, I'm going to put in g of x and then minus 1, right? So I just rewrote this, but I just left space for all those different things, right? Or I left space for the g of x function to go in. So I'm going to put g of x here, which is 5x. I'm going to put it here, right? And now we just operate. So I'm going to do exponents first. So 5x squared is going to be 25 x squared, and then plus 5x minus 1. And there's nothing we can do with that, right? That's simplified. There are no more like terms. So that would be our answer for that one. All right. Number 6, same thing, right? G of h of x. So now I'm going to input h into g, right? So h is going to go into g. And so here's h. So I'm going to put it into g, right? I'm going to put it in here for x. So I'm going to rewrite this function as, I'm going to write the g function, right, as blank plus 2. So instead of x there, I'm just leaving a blank space so that this can go in there. All right. And then we can just operate right here. There's nothing outside the parentheses to multiply by or anything, no negative out front. So we can actually just ignore the parentheses and just combine like terms. So it becomes 2x squared, and then negative 3 plus 2 is negative 1. And that's it. Okay. Now if we do, let's see, now we're going to do h of g of x. Okay, so now we're going to take g as the input function, right? So we're going to put g into h, right? So g in for h. All right, and so what we'll get is I'm going to rewrite this as 2 blank squared minus 3. So I'm just rewriting the h function, right? But instead of putting an x, I'm just leaving a blank. because what I want to put in there is g of x, which is x plus 2. All right, now we just operate. So here we have to square. So remember, when we square this, it's going to be x plus 2 multiplied by x plus 2. And so x times x is x squared. Let me see. And then x times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Then we can combine like terms here. So we get x squared plus 4x plus 4. And then we bring down the 2, bring down the minus 3. So now we have to distribute, right? So now we're going to distribute this 2 to each term here. So it's going to end up being 2x squared plus 8x plus 8 minus 3. And then we have one more set of like terms to combine. 8 minus 3 is 2x. So our final answer will be 2x squared plus 8x plus 5. All right, so that's how we compose functions algebraically. We just input one function, all of it, in as the input for the other function, right? So we input it in one whole function as the input value for the other function, and then we just evaluate it from there. Just work it out.